during the break. Let me be real clear about it. Homework 1 hasn't been graded. To be honest, I'm really leaning at this point toward grading homework 1 by submission. And I probably won't post that on the Slack because I don't want just random people who never bothered to submitting it. But the problem is that it turns out that the logistics of managing 60 invitations to join people's GitHubs, not a good idea. When I did the assignment that way, I didn't think of that. I thought that I didn't realize GitHub would force me to actually do some affirmative action. I thought you could just invite me to be part of your GitHub and then I'd be part of your GitHub. That was naive. So I can either dig through all these emails and click on 60 invitations, assuming they haven't expired, well, 45 invitations these days, or I can give up, and to be honest, I'm sort of mildly leaning toward give up. If you want me to look at something from that first assignment, I'm happy to, but otherwise, I suspect we're just gonna give everybody full credit for doing it, and who submitted something and call it a day. Does that make sense? My apologies for that. That was not a well thought out assignment, but I learned something, and next time I will figure out some different way, although I have no idea what that way is going to be, but I'll figure out something. It's probably time for me to get the cat to put up a private PSU GitLab instance. Maybe I'll tell you about that. That would make a lot of things. So I want to talk about real quick. We'll see how real quick it turns out to be. I'm going to talk about collections real quick too, and look how that turned out. Is input and output. Because Rust.io is a little awkward, and so it's worth sort of mentioning sort of bugs and features and how you use it, because I assume some of you struggled with it a little. I still struggle with it a little from time to time. It's like, wait, how do I do this with Rust.io system? So if you're feeling that way, you're not feeling alone. It's not a bad I/O system. I think it's actually pretty nice. It's quite blazingly fast, as you expect. It tries to be able to do things zero copy when possible. But it's a little bit awkward. It feels a little like I'm doing I/O in C or C++, and neither one of those has an ideal I/O experience. I wish I had something like Python's I/O experience, but with Rust performance. But I don't. And part of that is legacy code. One of the cool things about the I/O system is it really works pretty well with sort of all three major operating systems. You can write code with pretty low effort that's generic across Windows, Macs, and Linux that does I/O, even for some fancy stuff. And so that's kind of cool. Another thing that's cool about it is that Unicode support isn't ideal, but everything does support Unicode in a reasonable way, which is nice for Facebook. Notice that the I/O is split across a whole bunch of parts of the standard library. There's stuff in standard : IO, as you'd expect. Standard : FS contains all the file system specific stuff, or most of it. Standard : path is an abstraction for managing paths. Standard : process provides you not only with processes, but with some primitives for communicating with processes. There's standard : net, which is where the networking code lives. Oh, this is a lot of things. I want to run through each of these really briefly, sort of give you the 10,000-foot tour, if that, of what's in that thing, and then you can, then I'll at least be able to say I showed you it, and that's pretty much the most I can hope. In general, the rule for I/O and Rust, sadly, is probably the Stack Overflow rule. We've talked in here before about how to use Stack Overflow, right? You go find an example that's close to what you want to do. You study it to understand how it works and how it might be broken. And then you write your own from scratch, but you now at least have some idea of where to look for the things you need to know to write it yourself. Does that make sense as a plan? In general, that's generally what I do, honestly, with I/O. Once you understand enough Rust to be able to read the Rust standard library documentation, which I hope you all do by now, then it's mostly a matter of finding where in that giant pile of random modules is the functionality that you need. And most of it is there. The stuff that isn't there is provided by external crates, and it's pretty nice. For example, crate that I didn't know where to talk about, the byte order crate is the very accepted standard way to do byte ordering in Rust, to flip things between big and little endian, and be able to read things in whatever endianness you want, and that sort of thing. And, you know, if you have those kinds of issues, which people occasionally do, you should be looking at the byte order crate. So let's just briefly breeze through some of these things. Why is traits linked here? What I linked to? Remember, oh, just back to the traits lecture. I see. I think actually that's the stupid Moodle trying to help me. It's like, oh yeah, you mentioned traits. You had a lecture called traits. I will link you back to traits. And there's structs linked the same way. Thanks, Moodle. But anyway, basic I/O is all about implementing traits, right? In particular, there are these read, buffer read, and write traits, which are actually the sort of standard traits of things that read and write things. Every sensible thing, that says including strings there, I think that's actually a lie, but it's complicated. But any sort of sensible thing that you expect to be able to read or write usually implements the read or write trait, and so you can just read or write it, just like it was whatever. There's a thing called standard I/O cursor, which is really a fantastic way of dealing with bytes from an arbitrary source. I'll show you an example of that in a bit. Read implies that the read will be unbuffered. That means, you know, if I ask to read 5 bytes, the operating system will be asked to read 5 bytes from a thing. That's not often what you want, and so often you want things that implement buffer read instead. Buffer reader instead, excuse me. And the buffer read trait implements buffer reader. That's sort of what it does. And there is no buff write struct. There's only a buff writer trait. Make sense? So read, buff read, and write. Read. This slide's messed up. I edited it yesterday and I still have it messed up. Let me try that again. Read, write, and buff read is a struct. All those other things are traits. And there is no buff write struct. But the point is that most of the things in Rust implement buff read rather than read, than some other kind of struct that implements the read trait. So you get this super trait that's the thing you want. And buff reader and buff writer are structs that implement a buffering wrapper. So if you have a thing that only implements read and write, you can say buff reader : new or buff writer : new, and you'll get a thing that implements buff read and implements write with a buffer. Instead of waving my hands more at this, I think it's better to start looking at an example. I need to think carefully about how to really make that slide. So this is a classic example, by the way, of why you might want to use a cursor. I'm here in the Rust playground, and oddly in the Rust playground, there's no real great way for me to do file I/O, because where would the file live? It's somewhere on the Rust playground. That doesn't sound like a thing. So what do we do instead? Well, we use the cursor trait. So what we're going to do is we're going to actually make some text and stick it in a vec of U8s by collecting its bytes up. And now I have a thing that's effectively a file. Once I wrap a cursor around it, then I've got a thing that can act like a file for the purposes of file operations. Nice. So there's a pre-formatted file with 3 lines in it. The first line has spaces at the beginning and the end. The second line has a space at the beginning. The third line doesn't end with a new line, but that's still 3 lines. Everybody agree? What I'm going to do is use some of these things to sort of clean that file up and print a cleaned version. And so I'm going to call my fake open routine, right? I deliberately, I'm like, well, let's just make this like an open, right? I could replace that line real easily with standard fs open blah, and it would still work, right, with a file name, and it would still work. By the way, why does open, what's that impl read thing? That's something that's not in the book that I think we've talked about before, but I want to remind people what the deal is with impl read. Anybody?
Does it mean that it can return anything that implements read?
It means that it returns something that implements read, right? And open gets to pick what thing that implements read it returns, right? In this case, it returns a cursor. But it doesn't even want the caller to know, or need the caller to know what kind of reader it returned, right? It returned a thing that can implement read. And so now all the caller can do with the result of open is whatever the read trait allows it to do, right? The caller knows nothing else about it. It doesn't know its size, it doesn't know what capabilities it has. All it knows is that it will fairly implement the read trait, and I can use the read traits methods. Make sense? Yeah?
Yeah.
Everybody? People in the back looking blankly. I know, it's a long day, it's a long thing. So I'm going to get that file, which right now a file is sort of a fake name. It's really just a thing that implements the read trait. I'm going to buffer that thing in case it wasn't buffered. It's kind of pointless for this string, but let's pretend I don't know that open returns a cursor over a string. And then I'm going to wrap over the lines. One of the methods that the buff read trait gives you is a method that, returns an iterator of lines, a lines iterator. And so I'm going to get that lines iterator, and I'm going to loop over lines in the file. And that's one of the places where cross-platform is kind of cool, right? That iterator handles, Mac style or Unix style or Windows style line endings. It's like, yeah, I can do that. It handles the empty line ending at the end of that third line. It's like, yeah, I can do that. So it's a very general purpose line splitter upper. And so each time I call, each time that iterator's next method is called, each time readers.lines' next method is called, it will go read a new line out of whatever it's supposed to be reading out of. And if it runs out of stuff to read, it will ask the buff reader to go read some more stuff and buffer it. And if the buff reader, when the buff reader does that, it actually asks the cursor struct, to please go get me some more characters from this string, right? There's a lot of layers of indirection here. The good news from a performance point of view is all this gets inlined basically, and the compiler just generates very efficient code that you don't have to worry about. So anyway, we get a line, then I have to unwrap the line. Why do I have to unwrap the line? Or I chose to unwrap the line. Why? What am I doing there? What's going on?
An error could have occurred when you were...
A read error, right? This code doesn't know that the thing it's reading from is a string, right? Maybe the disk died in the middle of my read operation and I got a read error back, right? In that case, you might want to handle it. So the line you get is actually a result line, standard IO error. And we just want the line, so we'll unwrap to get it. I'm pretty confident that unwrap will never fail. If that unwrap fails, I don't understand what's going on, right? Because it means my string has crashed. I don't know what that means. So I unwrap it, and then I'm going to use split white space and trim, which are standard methods on string slices, right? Because it turns out that this line is returned as a string, which is handy. String or an ampersand stir, I don't even remember. Anyway, I'm going to take it, I'm going to trim it, I'm going to split it at the white space, and then I'm going to collect its fields together, and then I'm going to join the fields back up, right? So I've effectively cleaned up all the words on each line of the file, right? I don't even care how many of them there are. There could be 3-word stuff in here, or stuff with lots of spaces in the middle, tabs. It's all good. Yeah? Cool.
Question?
Yeah.
So, I've actually read about this on the Rust documentation, and they say that unwrapping that line is kind of dangerous instead of using a match statement. Is that just because they're saying like, oh, you don't know what your input's gonna be.
Right. It depends on what behavior you want when you get an IO error, right? I mean, in this case, I'm pretty confident I won't get an IO error because I know that my string is what I'm reading from, and you don't get IO errors from reading from a cursor,
Yeah.
from a string cursor. But if I were reading from the disk, what do I want to have the thing do? Do I want my program to panic? Not so happy, right? What I probably want to do is return some sensible error message, print some sensible error message in a sensible place, and so I probably want to handle that result some different way. The normal thing you'd do here, if this was just some arbitrary function, is you'd have it return a result type, and you'd say line equals line question mark. Oh yeah, the question mark operator that returns an error to the, in the function, from the enclosing function if there's an error, and otherwise unwraps the thing for you. And somewhere up at the top level, you can't question mark anymore because you have to actually do something with the error, and you do something with the error at some appropriate spot. Does that make sense?
Yeah. So if you're literally just reading from string literals and it works one time, you know it's gonna work the next time, right? And
Well,
so
you kind of
wouldn't have
know
to-
it's gonna work. If the program compiles, you know it's always gonna work, right? I mean, the compiler has all the information it needs here to guarantee that you're reading from string literals. All you really need is to check all the types of reads and stuff. That's pretty much a proof for you. Your read won't fail with an error, right? Things can happen, but failing with a read error isn't really one of them.
Yeah.
And so you're all good. Yeah. So this thing, if I run it, how do I make 3 return 4? I don't know. Apparently can't count very well in Roman numerals, but then again, not that those were Roman numerals anyway. The actual Romans used I for 4. Yeah, look at that. Everything got all cleaned up super nicely, just like I hoped it would. We're all good, and all's better for you. Yay! And like I say, if I copied this down to my disk and replaced this column my open with standard : fs : open, yeah, then I could read text files and do the same thing. Yeah. Nothing magic about this. It's just a thing that happens to implement the read trait, which is all we really want to do. So that's basic I/O. Notice what we don't have to do. I've said this 50 times before, but it's worth saying it 51st time because it's so cool. What don't we have to do in this program? We have to close the file, right? When does it get closed? Well, when the enclosing function exits and it goes out of scope. In this case, that's main. The operating system would have closed it anyway, but Rust gets a chance now to do things like flush buffers and do stuff with it because files implement the drop, most things implement a drop method at that point.
Can you explain what a cursor is?
It's just a thing you wrap around something like a string to turn it into a readable thing. Actually, it's something you wrap it around a collection of bytes, and now that collection of bytes has the read and write traits. It's just a thing that provides the read and write traits. It's a struct that provides that implements the read and write traits on a collection of bytes, and it also implements the seek trait, and so you can actually seek inside your fake file. It's just a way to have a fake file.
Okay.
And, that's what I meant to say about this before we left it. This is cool for demos on the playground. It's also really cool for your tests. If you're trying to test code that opens files and reads or writes them, it's pretty common to use a cursor for that so that you can run the tests regardless of where the code's running, and it will actually test your reading and writing files. Make sense? Yeah.
So what's the difference between this and like a right-len statement, like a cursor and a right-len?
Well, Writeland takes a variety of things. It takes things that implement the read and write trait, but because it's a macro, it can also take things like strings, which do not implement the read and write trait, and deal with those.
Okay.
And so, yeah.
That's kind of boring, but okay.
Yeah, exactly. No, this is just a way to make something that acts from the point of view of most of Rust I/O exactly like a file. It's like, oh yeah, once you've got a thing that acts exactly like a file, you don't have to turn it from anymore. We'll see that again in a moment when we talk about networking. Because networks are the same thing, network connections are the same thing. They act like files as far as Rust is concerned, because they implement the read and write traits. And so, you can read and write them using exactly the same code you would have used to read and write. A TCP stream, you can read and write using the exact same code you would have used to read and write a text file. That's kind of cool. In C standard library, there's a similar thing through the some function that returns a file pointer on a string. I don't remember what it is. There's some function. There's certainly fdopen, which takes a file descriptor and turns it into a file pointer. So I can take my network connection, my socket connections, file descriptor, and make a file pointer out of it. This kind of hides it even farther under the hood, which is kind of cool. Standard in and standard out and standard error, unfortunately, in Rust are a bit special. It's really, really super annoying. They aren't treated like normal files, and they aren't treated sort of coherently the way C and C++ and Python do. They're considered sort of separate things. Also, they aren't variables anymore. They're functions that return a readable, writable thing, which is super annoying and super distracting, because now you got to make sure that thing that they return stays alive in order to satisfy the lifetime constraints of what you're doing, but there we are. And the thing they return are a stood-in struct, a stood-out struct, and a stood-error struct, respectively. It would be nice if they all returned a stood.io struct, but that would apparently be too much to ask, because they don't, and so you have to deal with that. So like I said, borrow rules will confuse you at first, because the compiler will be like, you dropped that, the output of std.io open paren close paren on the ground, and you'll be like, what even is that? Yeah, that's Rust. The other thing that's weird is flushing. I actually have an RFC partially written and a crate implemented so that you can do